In this video, we'll consider exercise 5A1. And in this exercise, we are given a utility function of one consumer, M times D, where M stands for the number of movie tickets and D for the number of DVDs. And then in part A, suppose the price of movie tickets equals 10 and the price of DVDs equals 20. And then we're asked to draw this consumer's income expansion path for any income between 0 and 100. And later on, we're also asked to draw the angle curve for movie tickets. So let's start with the income expansion path. So what is an income expansion path? Well, it basically shows, so it tracks the optimal consumption bundle in the MD plane as income increases. Okay, so as income increases, we'll have outward shifting budget constraints. So they should be parallel, of course. And then we have these points, right, where the budget constraints are tangent to the indifference curve. This is very sloppy drawing, but don't mind that. So these points are both on the income expansion path. That's the idea. Okay, so let me erase this for a moment. So what do we know about those points? Well, we know that at those points, the slope of the indifference curve is the same as the slope of the budget constraint. So let's start with the slope of the indifference curve. It equals minus the marginal rate of substitution between movie tickets and DVDs. And so it's minus MUM, the marginal utility of movie tickets, divided by the marginal utility of DVDs. So what's the marginal utility of movie tickets? So take the derivative with respect to M here, and we get D. So the number of DVDs. And similarly, the marginal utility of DVDs equals M, the number of movie tickets. So that's the slope of the indifference curve minus the marginal rate of substitution. So what about the slope of the budget constraint? Well, the slope of the budget constraint is minus the price ratio, PM over PD. And PM and PD are given in this exercise. It's minus 10 over 20 or minus a half. So right, all the points on the income expansion path have the property that the slope of the indifference curve equals the slope of the budget constraint. So if we equate minus D over M with minus a half, or let's write this a little neatly. So this is true if and only if this is true. And that tells us that on the income expansion path, the number of DVDs equals half the number of movie tickets. Okay, so now we're supposed to draw this for incomes between 0 and 100. So let's look at our budget constraint. Which reads like this. So clearly, if our income equals 0, then our consumption of movie tickets and DVDs equals 0 as well, because we don't have the money to buy them. Now let's solve this for y equals 100 as well. So we plug in this into the budget constraint to find our optimal consumption bundle at an income of 100. And we find the number of movie tickets equals 1/2, and therefore the number of DVDs equals 2.5. So let's consider this plane again. So if our income is 100, then we consume over here. If our income is 0, we'll consume over here. So what about everything in between? Well, everything in between follows exactly this linear function, d equals 1/2 m. So it's a straight line going through these 2 points. And so this is our income expansion path. Okay. Right, so what does that mean? Again, if we have a budget constraint like this, right, where our income is 100 and the price R is given, then it's exactly tangent to this indifference curve. Now, let's say we have a parallel one over here, right? Our income is less, but the price remains the same. Then this point is also on the income expansion path, so that means this budget constraint is tangent to an indifference curve like this. Okay. So that's what that means. And all we needed to do here was draw the income expansion path. So basically, we needed to draw this function. Now we were asked to draw it for all incomes between 0 and 100. So this is the last point on the curve, or on the line. Okay, moving on. So then we're also asked in this exercise to draw the angle curve for movie tickets. So the angle curve for movie tickets is drawn in the ym plane. You put y, or income, on the y-axis, and in this case movie tickets, m on the x-axis. And so this curve tells us how much movie tickets we consume as our income increases, or changes, if you will. So how do we figure that one out? Well, again, we know that the number of DVDs equals 1/2 times m. So we can use this function over here. So we have this budget constraint, right? Then we know this is true. And so we find that this is true. So we find income as a function of movie tickets, or of course the way to think about it is the movie tickets as a function of income. And so we can draw this line. So it crosses here. So this is our angle curve, just a straight line through the origin and this point, this function. Okay, so that's part A. Then we can move to part B. So in part B, the price of DVDs is still given by 20. Income is now fixed at 100. And we are asked to derive the demand function for movie tickets of this consumer. So what does a demand function look like? Well, it's the quantity consumed, which in this case equals M, as a function of its price, right? So we leave the price as unknown and we figure out this consumer's consumption of movie tickets as this price varies. Okay, so recall that the MRS was D over M. Now the price ratio in the price ratio we leave PM as an unknown, but we can plug in PD equal to 20, so the price ratio now equals PM over 20. Now in the optimal consumption bundle, the MRS equals this price ratio, or the slope of the indifference curve equals the budget constraint, which is the same thing. So this is the ratio in which DVDs are consumed with PM as an unknown. And then we go back to the budget constraints. So that one reads like this, where we can plug in PD and Y. We plug in this in here. $20 times PMM over 20 just equals PM times M. And solving for M, we find the number of movie tickets consumed equals 50 over PM. And so this is our demand function. Movie tickets is a function of its price. So that is part B. So we leave the price as an unknown, and we solve for the number of movie tickets in the optimal consumption model. Okay, then moving on to the final part of this exercise, part C. So here it says, well, initially, this is the situation. Price of the movie tickets are 10, price of DVDs 20, and income equals 100. But now suppose that the price of movie tickets doubles. Okay, so this changes into this. Determine how this price increase affects demand for movie tickets. Well, we have just derived the demand function, so why not use it? So the change in consumption of movie tickets as a result of this price increase equals plug in 20 minus plug in 10. So that's 5 over 2 minus 5, which equals minus 2.5. So as a result of this price increase, the number of movie tickets consumed decreases by -2.5. So that is the total effect. Let's say the total effect of this price increase on the consumption of movie tickets. And we are asked here again to decompose this into the income effect and the substitution effect. So recall that we can split this total effect into the substitution effect and the income effect. So how do we do that again? Well, consider this plane again. So the initial situation runs like this. So this is the initial budget constraint. And then we found the optimal consumption bundle over here. So this was the situation. U bar. And now the price of movie tickets has doubled, so the new budget constraint looks like this. And it turns out now we're consuming, it's not completely drawn to scale, you get the idea. So now we went to this situation. Okay, so this is the total effect. So how do we decompose this effect into the substitution effect and income effect? So let's start with the substitution effect. So we know with the substitution effect that we keep the change in relative prices, right? So we keep the slope of the new budget constraint, but the consumer doesn't feel poor. Her purchasing power hasn't changed. So we remain on the old indifference curve. Okay, so what that means is we need a line parallel to this new budget constraint, right? That will have the same slope. But which just touches the, which is tangent to the old indifference curve. So hopefully you get the idea here. So this is a line parallel to the new budget constraint and just touches the old indifference curve. And so if we find this point, then this will be the substitution effect. And what remains of the total effect equals the income effect. That's how we decompose this. So that leaves finding out what this point exactly is. So what do we know about that point? Well, utility is the same as before. Okay, so basically, let's call this point MSE. Okay, so we know this, right? If this equals DSE. And we know that U bar equals 5 times 2.5. Which equals 12.5 or 12.5. So the first thing we know is that at this consumption bundle, our utility equals 12.5, or this consumer's utility. The second thing we know is that the new budget constraint is tangent to the indifference curve here. So the slope of the new budget constraint equals -1. And the reason is that PM equals PD equals 20 in that case, right? That's the new situation. And the MRS is still, I should write, the slope of the indifference curve is as before, minus d over m. So we know at that point that d over m equals 1 or d equals m. So now we have two equations and two unknowns, namely this equation and this one. So we can combine those to find MSE times MSE equals 12.5. Which means MSE equals the square root of 12.5, which is approximately 3.5. So looking at the graph, the substitution effect here is minus 1.5. We went from 5 to 3.5. Okay, so the change in consumption due to the change in relative prices, keeping purchasing power constant, is the substitution effect equals minus 1.5. And so what is left is the income effect, which equals the total effect minus the substitution effect. And the total effect was minus 2.5. And the substitution effect equals minus 1.5. So the income effect equals minus 1. And that concludes this exercise.